This is an optimized profile descent. It's a type of star that's designed to take a plane from here to here, with minimal radio transmissions between controllers and pilots, and reduced fuel burned. It's a fairly simple idea, but in the National Airspace System, where small changes can have big impacts, implementing even the simplest idea can be a complex undertaking. To make sure OPDs work as well as they can, we've turned to the best experts available, the people who work the system every day, pilots and your fellow controllers. They've been instrumental in the design of the new procedures, and their hard work is paying off. Once controllers get accustomed to using OPDs, the benefits become clear. Here's how an OPD works. A controller issues a clearance.
Transglobal 123 Washington Center, roger. After HARP, descend via the Gibbs to arrival. Dulles altimeter 2992.
The pilot reads it back.
Transglobal 123, after HARP, descend via the Gibbs to arrival. Dulles altimeter 2992.
The pilot programs and monitors the flight management system, which keeps the airplane on a steady and predictable path. At this point, the controller doesn't have to issue any more instructions, unless there's a need to revise an altitude or a speed, or take the aircraft off the OPD for separation or sequencing. The controller can concentrate on the big picture, like scanning for conflicts and managing arrival and departure flows. And pilots can remain focused on other tasks, such as checklists, scanning for traffic, and other communications. Plus, with fewer radio communications, the frequency is available for other transmissions, and there's less chance for misunderstandings between pilots and controllers. With an OPD, the controller knows where and how fast the aircraft will be flying, and can work other traffic around that predictable path. As the plane flying the OPD continues on its designated path, its engines are running at or near idle. It's burning much less fuel and sending far less CO2 into the atmosphere. The operator is saving money, and the impact on the environment is reduced. It's a win-win.
We're making it much more affordable for the common man and woman in this country to fly. And by doing that, it keeps the industry strong and profitable.
The goal of the procedure design is to allow the use of the OPD in most conditions. But as you know, dozens of variables impact how each procedure functions.
Weather, winds, the other airplanes in the sector, the performance characteristics of the airplanes. It's tough to foresee all the potential issues.
In fact, it's impossible. That's why NATCA, the FAA, the airlines, and other stakeholders are committed to improving OPDs after they're implemented, making them work for controllers and the pilots you guide. So don't be afraid to speak up if something's not working as well as it could. Your input will help improve the procedures. And don't forget that you can always take an aircraft off an OPD and put it back on if the situation calls for it. But if you do, be sure to remember a few things. When pulling a flight off an OPD, controllers will have a pilot maintain an altitude. If the aircraft is too high, it may not be able to descend quickly enough to comply with the altitude restriction for the next waypoint. Make sure to turn a pilot back onto the procedure with enough time to hit the altitude for the next waypoint. You have a few options when putting the flight back on the OPD.
Well, from a flight crew member's perspective, the easiest way to get back on an optimized profile descent is for the controller to re-clear us back to a fix on the profile and then clear us to descend via.
Proceed direct Kilmer, descend via the Gibbs to arrival.
This way, the airplane can calculate the most optimized altitudes to fly through the different fixes and still meet the published constraints, both speed and altitude, in the descent to the end of the star.
But remember, if you clear an airplane to a fix on an OPD that does not have an altitude restriction, you must issue an altitude to the aircraft. If you clear an airplane to a fix that doesn't have a speed restriction, issue a speed if you need it. OPDs are being used successfully by controllers every day. They can be a significant change to the way you control traffic, but given the chance, they can prove to be an effective tool, providing the most efficient path from cruising altitude to the ground.